Hey everyone. So in this video, I'm going to show you how to make a custom gameplay effect, just in case you want to do it in C++ instead of blueprints. It's pretty easy. Let's go. Alright, here we are in our attribute set that we created a while back. First of all, before we do this, I'm going to add in something that the Action RPG has, and it's the damage attribute. This is a temporary container for the damage, so that you can calculate several different executions up to a final damage in case you want to do something more complex. It also allows us to apply such as 35 damage rather than directly modify the health by subtracting 35 whatevers. So this is just a cleaner way to do that. So we're going to do that real fast. I'm going to just grab that header, put it here, change this to on rep damage. And this is going to be an F gameplay attribute data called damage. Attribute accessors U hopper attribute set damage. There we go. And we're going to go down here and do another U function, virtual void on rep damage, const F gameplay. What is it? Attribute data. Reference. Hold value. Okay. There we go. Now we're going to come over here. We're going to make sure that we remember to add that do rep lifetime U hopper attribute set damage. And we're going to do that. And I'm just going to copy that, stick that there, and change that to damage. Okay, so that attribute now exists. Now we need to modify this post-gameplay effect execute. This is the complex function that moves our information around to various functions and handles the changes and stuff, such as handle health changed. You see that's where this gets here, and we're clamping, all that fancy stuff. So, let me check my notes here. It looks like right here before the get health attribute is where we need to add in our damage stuff. So if data.evaluatedData.attribute is equal to get damage attribute, we're going to get the source actor. And again, all of this is out of the Action RPG example project. We're going to make a source actor, which is a null pointer, and a hopper base character pointer, source character, which is also a null pointer. Alright, if source and source ability actor info dot is valid and source ability actor info avatar actor is valid, so we're checking all of our pointers to make sure all of that is good to go. Then we're going to get a controller pointer. This is our source controller. Initialize that also to a null pointer. Source actor is equal to source ability actor info avatar actor dot get. So we're filling in that source actor with the avatar actor. And our source controller we're going to fill in with the source's ability actor info player controller dot get. So now we have that. And now we're going to check again. If source controller is equal to a null pointer, I'm just going to do that. And source actor. So we're checking for null pointers here. So we don't want to continue if they're null, so we're going to create a pawn pointer, which is going to be initialized to, we're going to cast to a pawn, the source actor. I don't know why there's an extra bracket there. There should be one right there. It just messed up. Oh, I see what's going on. It got all funky. Okay, now it's fixed. Our source controller is going to be equal to the pawn get controller. Okay. And that can probably be const, can't it? There we go. Alright, so we're going to use the controller to find the source pawn. If we have the source controller, and that is a valid pointer, we're going to take that source controller and we're going to take our hopper base character and cast our source controller get pawn to that base character, right? Oh, sorry, that is my bad there. That should be source character. Okay, that's better. Else, source character is equal to cast a hopper base character source actor. So we're going to get that guy however we can. So now we're going to set the causer actor based on context if it's set. So if context dot get effect causer source actor is equal to context dot get effect causer. Okay, so now we've gotten all of our dudes and cast them to the correct stuff that we need. Now we're going to extract some stuff. So we're going to try to extract a hit result. I'm going to make a hit result. Hit result. And if context.get hit result. Hit result is equal to dereferencing the context's get hit result. Alright, now we're going to store a local copy of the amount of damage done and clear the damage attribute. So we need a const float local damage done and initialize that to get damage. And we're going to set the damage and clear it to 0. Now if our local damage done is greater than 0, we're going to apply the health change and then clamp it. Alright, so we're going to take our const float old health. Okay, we're going to initialize that to get health. And we're going to set the health, F math, clamp, old health, minus the local damage done at 0.F to get max health. So we're clamping that damage so that we're in between 0 and our max health. Now if our target character is a valid pointer, this is proper damage, target character, handle damage, local damage done, the hit result, the source tags, the source character. I'm going to go down to a new line because I can't see. And the source actor. Right, that's what this guy needs for handling damage. And now call for all health changes. Target character, handle health changed, subtract the local damage done, so a -1 of that, and source tags. Okay, that's that. Now we just change this to an else if, so that's the health attribute, right? And we can put in, I've got some comments here just to make this better. So handle other health changes such as from healing or direct modifiers. We clamp it, and then we call for the health changes, all right? So all of that we just wrote right there is to handle damage so that you can do, again, complex stuff. What's happening here? I see a little squiggly. What'd I do wrong? I have an extra parentheses. Okay. Woo! Alright, so now we're done there. I'm gonna go ahead and compile because we need to make a new C++ class. Okay, we're here in the editor. Before we continue, we're going to just test what we just did. So go to your gameplay effect damage. Down here, the attribute, I'm going to change that to our new damage attribute. We're going to do override and 35. So we're taking that 35, that is the damage value. That 35 is the damage, and it should apply like we're directly modifying the health like last time, but it's now a more complex damage. So, boop. Yes, okay. Our changes still work. Okay, in order to create a custom damage, so we're going to convert this guy to be C++ for whatever reason you might have. So we're going to go to Tools, New C++ class. We're going to look for Gameplay Effect. Hit Next. We're going to make this a Hopper Damage Effect. And we're going to put this in Public, Core, and Abilities. Create the class, and we'll go to the code. Okay, you remember how I said this was easy? We did the hard part, doing the damage attribute code. This is the easy part. Just make a little constructor. I'm going to put that under a public header. I don't know if it needs to be public or protected. I'm not sure. Okay, in the constructor, what do we need? We just need to create that stuff, the damage, right? So we need a gameplay modifier info, and we'll call it damage info. Alright, take that damage info, get the attribute off of it, and we're going to set that to uHopper attribute set. So that'll grab the include. We want to get our damage attribute that we just made. The damage info, we want to grab the modifier OP, the modifier operator. We're going to go eGameplay mod op override, and then damage info dot modifier magnitude. Alright, so this is where we set the amount of damage that we're actually going to do with this guy. So the effect modifier magnitude, we need that struct, and we're going to give it 35.f for a scalar value. You can make different modifiers with more complex stuff if you go check out that structure. And we're going to take the modifiers array, which exists from the parent gameplay effect class. We're going to add our new struct. Boom. That's it. That's how you add a modifier with the basics. And if you want to do a queue, such as if you're doing a spell, not a spell, particle effect. Yeah, that's what I meant. So we're going to create a damage queue here. We're going to make a tag container called our damage tag container. We're going to create an array of f-string called tags. Alright, and tags, we're going to add in, this is where you would put in the queue, the tags that you make in the editor. So I've got a gameplay queue.punched. So I'm adding that to the array. Now we want to grab our gameplay tags manager, which is a singleton, so we want to get it. We want to request gameplay tag container. We pass in the tags array that we made, so that holds the actual string for the tag that it's searching for, and then we want to pass in the damage tag container, which it will fill because it's by reference. You can see the little ampersand there. So it's going to fill that damage container with the gameplay tag container that is extracted from the gameplay tags manager. So now we take the damage queue and we go to the gameplay queue tags and we set the queue tags to that damage tag container. Then the gameplay queues, which is an array from the parent class of the gameplay effect that we inherited from, and we're adding that damage queue. Alright, those are the two things to replicate what we did in Blueprints. We now have the effect, the actual damage, and we have the queue to play off a particle effect. Let's go ahead and compile and go back to the editor. Okay, we are back in the editor. I'm going to go ahead and open the original damage here so we can compare. As you can see, we have gameplay queues right here with our gameplay queue punched. And if we scroll down, here's our modifiers with one array member, attribute set damage, override, scalable float 35. Alright, so we're going to create a new blueprint class. This time it's going to be off our Hopper damage effect. And we're going to call it GE, we'll call it damage test. And ideally, this should be identical. Hey, look at that. Gameplay queues. We've got our gameplay queue.punched right there, just like we added it in the C++. And if we scroll down, there we go. Hopper attribute set.damage is set for the attribute. We've got our override for the modifier operation. And we've got a scalable float and 35. Okay. So if we go to our punch, right here, apply gameplay effect to target, and we switch it to our gameplay effect damage test, our new C++ class, with the it's a blueprint child off of the C++ class. And if we hit play, everything should be the same. And it is. We're reducing health, we're applying damage, and all of it comes from just C++ coding. So if you want to do some more complex stuff and you want to do it in C++, there's your starting point. That's how you set up a gameplay effect with C++. I feel like I say C++ a lot. Anyway, I'm starting school again in a week, going back for some computer science, so there might be a slowdown in these videos. I've probably got quite a bit of homework headed my way. I will try to make some more videos for you when I have free time. Otherwise, have a great weekend.